స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. ఒక స్క్రీన్ షేర్ కాదు. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. వేరే స్క్రీన్ షేర్ స్క్రీన్ షేర్ కాదు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ అందుకు ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? రికార్డ్ అయ్యే ప్లే స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్క్రీన్ షేర్ స్క్రీన్ షేర్ కాదు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ అందుకు ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. ఇది స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్క్రీన్ షేర్ ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. స్క్రీన్ షేర్ కాదు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. ఇది స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్క్రీన్ షేర్ ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. స్క్రీన్ షేర్ కాదు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. ఇది స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్క్రీన్ షేర్ ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. 2 minutes లాగలేదు. స్క్రీన్ షేర్ సెలెక్ట్ చేస్తారు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. స్క్రీన్ షేర్ ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. 2 minutes లాగలేదు. స్క్రీన్ షేర్ సెలెక్ట్ చేస్తారు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. 2 minutes లాగలేదు. స్క్రీన్ షేర్ సెలెక్ట్ చేస్తారు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. స్ట్రీమింగ్ ఫెయిల్ అవుతుంది. ఒకసారి చెక్ చేయండి. వైట్ స్క్రీన్ వచ్చింది కదా. 2 minutes లాగలేదు. స్క్రీన్ షేర్ సెలెక్ట్ చేస్తారు. ఇవన్నీ సెలెక్ట్ చేయలేదు కదా. కానీ ఇందాక టాక్ చేసింది రికార్డ్ అయిందా? కంప్లీట్ స్క్రీన్ క్యాప్చర్ కదా. సౌండ్ ఎక్కువైంది. బ్యాక్గ్రౌండ్ నాయిస్ ఎక్కువ వస్తుంది.
ఇప్పుడు చూడండి.
ఒకసారి స్టార్ట్ చేసేస్తాం. ఇది 95% దగ్గర అయిపోయింది.
సార్ రెండు ఇన్స్టాల్ చేస్తే మైక్ ప్రాబ్లం అవుతుంది సార్. మైక్ ప్రాబ్లం అవుతుంది.
ఏదండి
జూమ్ రెండు ఒకసారి తీసుకోవాలి లైవ్ స్ట్రీమింగ్.
95% దగ్గర అయిపోయింది. చూద్దాం, ట్రై చేసి నెక్స్ట్ వీక్ నుంచి కంప్లీట్ కొన్ని ట్రయల్స్ చేయాలి ఫస్ట్ బిఫోర్ వీ గో టు ద లైవ్ స్ట్రీమ్. ఇది జూమ్ 95% కంప్లీట్ అయిపోయింది. ఇది ఇట్స్ నాట్ ప్రోగ్రెసింగ్. టూ మినిట్స్ లైవ్ స్ట్రీమింగ్ స్టాప్ చేయి. 2 minutes లైవ్ స్ట్రీమింగ్ స్టార్ట్ చేయి. అది సెటప్ అయిపోయిన తర్వాత దెన్ వీ విల్ కనెక్ట్ విత్ ద లైవ్.
లైవ్ స్ట్రీమింగ్ మళ్ళీ ఎంజాయ్ చేసి మళ్ళీ రీస్టార్ట్ చేసుకోవచ్చు.
అదే లైవ్ స్ట్రీమింగ్ స్టాప్ చేయలేదు, స్టాప్ అంటున్నా నేను.
మళ్ళీ కొత్త ఈవెంట్ క్రియేట్ చేసుకుని
ఇంకోటి న్యూ థింగ్స్ క్రియేట్ చేయాలా?
అందుకనే
ఇది పెండింగ్ టైం చూపిస్తుంది. వైట్ వైట్ స్టాప్ చేయి. 2 minutes లైవ్ స్ట్రీమింగ్ స్టార్ట్ చేయి. అది సెటప్ అయిపోయిన తర్వాత దెన్ వీ విల్ కనెక్ట్ విత్ ద లైవ్.
సార్
స్టాప్ అంటున్నా నేను. మళ్ళీ కొత్త ఈవెంట్ ఇంకోటి న్యూ థింగ్స్ క్రియేట్ చేయాలా? Okay, for today just proceed with this live streaming. Okay, all of you, good morning. Sorry for the delay. A little setup work is pending with this. Suhas, 1 minute please. Suhas. నా వాయిస్ నాకు ఎక్కువ వస్తుంది, అదొక్కటి సెట్ చేయవా? ఇంకేమవుతుంది?
ఎక్కువ అంటే ఒకసారి చెప్తాను.
Proceed with this. నా వాయిస్ రీచ్ కాదేమో.
రీచ్ అది జస్ట్
ఒకసారి స్క్రీన్ కన్ఫర్మ్ చేసుకు వచ్చేస్తుంది. రైట్.
మీకు ఏమన్నా బిల్ వస్తుందా? జస్ట్ 1 minute ఇలా ఉంటుంది.
So here.
స్క్రీన్ షేర్ చేయండి.
Yes. And that is okay. Sir, are you getting my voice, sir, and screen? Sudhir, Sandeep, Siva, Afroz, please confirm.
Sir.
Okay.
Yes, sir.
Yeah. Okay, sir. Yesterday we discussed about the importance of statistics and limitations of that statistics, how machine learning will help you. and when you need to go for neural networks and deep learning and NLP with ML or DL.
There is some window, I think it is blocking the notepad. Will you just make it slide or hide it?
Are you getting complete screen, sir?
There is a
I mean,
small window is opened, I think it is blocking the notepad.
1 minute, I will check now. Full screen. Now confirm me.
No, we are seeing the neural network, but after that what you type we are not able to see. There is one window there. One window.
Neural network, deep learning and NLP.
So deep learning and NLP I have typed it. Are you able to see these last 2 lines?
So, we are able to see, everyone is able to see. There is some problem. Buffering is there.
Okay.
Time gap is there.
So here I am able to see everything. I think for the Zoom audience, this will be like that. Do one thing, sir, all of you go into the Sriram trainings, because already the session is being streamed. Do one thing, go into Sriram trainings. The channel, YouTube channel. Go into this one, please. Go into Sriram Trainings YouTube channel and subscribe into that one. The session is being streamed with data science and AI. All of you Zoom team, so please go into that one. I will disconnect this meeting, all of you. That Zoom meeting I will disconnect. All of you get into that Sriram Trainings. Yes. So we will proceed with this one. Come on, sir. Yesterday's discussion is about statistics, machine learning, neural networks, and deep learning and NLP. A quick summary about all these things. Statistics is a scientific approach to do data analysis. So here scientific approach means any conclusion should be made with some mathematical measurement proof. I told you one example of correlation. This technique is generally used to understand the dependency between two variables. Example, correlation between temperature and ice cream sales. Suppose I got reply my result is like 0.97 something, which is a positive value. That is greater than 0. The understanding of this one, there is positive dependency between two variables t and ice cream. That means as one variable increases, second variable will also be increased. Similarly, as one decreases, second one will be decreased. For example, if I apply correlation between the temperature and sweater sales, if I got a reply like this, minus 0.78 something, this value is less than 0, that means negative. That means there is, your understanding should be, there is negative dependence. Between two variables. That means both variables does opposite direction journey. That means as one increases, second one will be decreasing. As one decreases, second one variable value will be increasing. This is what our basic understanding from this. So whatever the conclusion you are making here, whether it is a positive dependency or negative dependency, for that conclusion there should be some mathematical measurement proof. Without this mathematical measurement proof, you should not conclude anything as per ethics of the statistics. That is the meaning of this one. Statistics is a scientific approach to do data analysis. This analysis includes of predictions, and forecasting. And difference between this prediction and forecasting also I explained in last class. A simple difference. Prediction based on some input variables. Estimate value of target value. We discussed one example about it in last class. Based on age, weight, height. Estimate value of cholesterol of a person. So you are going to do some prediction, means first of all there should be some relationship, that means some dependency between input variables and output variables. Then only you can do such kind of predictions. Or else based on age, experience, you are going to estimate value of income or salary. So in the first example, age, weight, height are the inputs, cholesterol is the target variable. And in the second example, age, experience are the input variables, income is target variable. So based on some input variables, if you are going to estimate the value of the target variable, that is called a prediction. If it is forecasting, based on past timeline of data, estimate value of future value of same variable. Don't worry about the notes. These notes I will be sharing with you. Estimate value of the same variable. Example, you have 10 days of temperature data with their values. Based on last 10 days, Estimate 11th day temperature. So here input variable temperature, but past date. Output variable, that means target variable, also temperature. So this kind of estimation is called forecasting. In statistics we have different techniques and different models for predictions and for forecasting. Of course, in data mining and machine learning industry, you have more advanced models to do the forecasting and predictions. And the thing, statistics can do all the things, but finally statistics has limitations. The limitation simply it can identify. That means the traditional techniques of statistics, what I mean is not entire statistics. Okay, the traditional techniques of the statistics, it can identify simple patterns. Patterns in data, but not complex patterns. So for this, in last class we discussed some examples. Okay, suppose I want to predict age, weight, based on age, weight, height. I want to estimate your BPR or your cholesterol. So this kind of simple predictions statistics can do. But if I give some image based on image of a person, that means I am taking a pic. If pic is input, generally picture means that is a three-dimensional matrix. The complex data structure will be there. Is a RGB color matrix. R is one dimension. G, green, that is one dimension. And B for blue, that is another dimension. So generally image is a three-dimensional pixel matrix. The pixel value is generally from 0 to 255. Okay, 0 to 2, actually total 256 if you start counting from 0 to 255. Got it. Such kind of complex data structures, if I give more number of variables, if you flatten the image, more number of variables will be there, more patterns will be involving into that one. Such kind of complex predictions cannot be done with statistics. Of course can do, but accuracy will be very less. Okay, based on image, predict gender or predict age of a person. Such kind of things, stat will give wrong predictions, because this is simply complex. So complex patterns are involving into this one. So for such kind of things, simply solution, machine learning. So in the case of machine learning, there are different types of approaches are there, like supervised learning, unsupervised learning. Forget about these two things. Very soon we are going to step into this machine learning concepts. There we will discuss what are all the different types of the approaches. Especially what is a machine learning is, simply you can comment like this. Machine learning is an approach. Is an approach to train mathematical models. Okay, is an approach to train mathematical models. Here, mathematical model means is an equation. That means is a math equation. But every mathematical equation is not a model. Is not a model here. The math equation should give prediction. If that particular mathematical equation is able to do the predictions, then only you can call it as a model. Okay, so that means simply you can comment like this: mathematical predictive equation is called model. So here, suppose you are machine learning engineer. That means now you are the trainer. But what about your learner? Here learner is the math model. Example, let's say linear regression. The mathematical formula for this in the matrix style, y equal to x dot w. Treat that x as input matrix, y as target matrix, w is weights matrix. This is one mathematical predictive equation in linear algebra style. Same thing in geometrical style. In a normal, you can say simply like this: y equal to a plus bx. This is exactly equal to y equal to mx plus c of your basic mathematics. Got it? So this is the first one is equation in the matrix style. Second one is normal style. Whatever it may be, this is one predictive equation. This predictive equation is called mathematical model. So here the learner is mathematical model. Trainer is machine learning engineer. But to train this model, you need some weapon, you need some instrument. Data is instrument here. Using data. Okay, ML engineer will train the model. So data should contain two things here. Number one, input features. That means input variables. Input variable values. And second thing is labels for them. Labels means target variable values. Got it. By using these two things, we need to train the model. So during training, what the style is, the style of training. So which is some extra discussion when compared with the last class. Just observe the style of training and style of learning by the model. From your side, this is style of training, but from model point of view, this is style of learning. Okay. Style of learning by model, how it learns, because the model is a brainless. Previously, you are a trainer, I am your student. You have brain, I have brain. You have thinking ability, I have thinking ability. So you can train me easily. Understand? But here the thing is model. Model means one mathematical equation. But mathematical equation doesn't have brain. It doesn't have brain. Okay. Then how it learns? That is a question. Just observe the style of learning here. So let's talk about predictive equation. Y equal to y for prediction, x dot w. Okay. Initially, in the step 1, what it does is, here before step 1, here x is input matrix. And you can call it as a feature matrix. So how to prepare this feature matrix and everything, step by step we will be understanding once this overview part completed. And y equal to label matrix. Before training your model, you have to prepare two matrices, one input matrix, one output matrix. Okay, this is label. Label means output values. Output values of the given data. And W is weight matrix. That means coefficients. Okay, this is treated as knowledge. Observe the steps here. Step 1. In the beginning it takes random weights. And step 2. By taking random weights it applies prediction. The prediction, for the prediction, simply the symbol I am giving y cap. Y cap for the prediction. Y cap equal to input matrix into weight matrix. Okay. After that, step 3. It calculates error in prediction. How to calculate that error? What is the mathematical formula? All these things we will see later. It calculates error. Suppose in the first I got error like this. Generally there is a technique to find out error, mean square error. This technique we will use, mean square error. Forget about the terminology. Simply I am doing error, calculating error. For example, in the beginning iteration I got error of 180. Okay. Next, what it does is, in the step 4, to reduce that error, in next iteration, it applies derivative, mathematical derivative. This derivative simply called as gradient. Gradient, I write in the next line. It applies derivative. So don't worry about that derivative and what is the equation for it and everything. First I will explain complete, when we step into this part, I will explain complete mathematical background of this one, and with Python and with R how to implement this one you will be learning. Okay. To reduce that error in the next iteration, it applies derivative. Okay. And modifies weights with the latest weights. So this means this derivative will produce latest weights. Latest weights. Okay. So previous, in the beginning it has some weights here. Look into this. In the beginning it has some weights, but that is the wrong weights. Randomly it has taken some weights. Because of the wrong weights, one biggest error you got it. Next it targets how to reduce that error. In order to downfall of the error, it applies derivative. The derivative will produce new weights. After that, it modifies the previous weight matrix with the latest weights. Okay. That means now knowledge, if you treat that weight as a knowledge got modified. Okay. Next, step 5. That means then it applies again prediction. Applies prediction with latest weights. Got it. Actually this step 2 onwards you can treat it as iteration number 2. The step 2 onwards you can treat it as iteration number 1. Before first iteration, what it is doing, it is taking random weights. By taking random weights, it is applying prediction and calculating the error. Here applied the prediction and calculating the error. There are different techniques how to compute the error of a prediction. Got it? So I got a biggest error. To reduce that error, it is applying derivative. It is producing new weights. After that, The old weights will be modified with latest weights. That means knowledge got modified. Now with fresh knowledge, fresh random weights, again it is applying prediction. Okay? That means second iteration. Now think that. After that, step 6. With latest prediction, again calculating error. So previously I got error 180. Now I got error 150. So what happened here? Error got. Mr. Prasad, don't worry about the notes. I share you these notes. Just to keep an observe this. Now what is the error now? 150. Okay? So this error got reduced when compared with previous iteration. Again it is applying. Now you are in second iteration. Again it is applying derivative. Once derivative is applied to reduce that error, latest weights. Again, old weights are going to modify with latest weights. Got it. Now again, knowledge got modified. Knowledge got modified over here. Got it. So that means this knowledge, that means in the second iteration knowledge, this knowledge is better than previous iteration knowledge. That means these weights are better than previous iteration, which is the first iteration. Again iteration 3. Repeat the same step. Prediction, error, derivative. Prediction, error, derivative. In every iteration this will be the step. Suppose in the iteration 3, after doing the same thing, this time I got error 100. Again weights will be modified after completion of the derivation. Okay, now iteration number 4. Let's say I am talking about only error. Error is suppose 90. In this way, a lot of iterations happen. Maybe iteration number, think that iteration 101 is going on now. Okay, iteration 101. Here I got error 5. Iteration 102. Think that I got error 2. Still decreased. Iteration number 103, I got error of 2. What happened here?